Next, star delta transformation. So this is the configuration of connection. So the star connection of resistors is going to be like this. Okay. So all of the resistors, they are connected to a common point. And what about delta? Delta is going to be like this. It is like a closed loop. Okay. Now how can we convert from, we can convert from one form to the other. How to convert, that is what we are going to see in the star delta transformation. Here we are not going to go with the derivation. Whatever techniques we have used till now, we can use the same circuit analysis techniques to find out this expression, but we will skip all of that. It is not necessary. It is enough if you can remember the final result, right? So now we will start with the star to delta. That means star is given, how to find the delta values. So we will take the star connection like this R1, R2 and R3. Okay. So these terminals we will mark as A, B and C. Okay. Now we want to get a delta connection like this. Okay. Across the same terminals. Okay. So we will just draw it a little separately, just for the sake of clarity. Okay. So now this point is A, this point is B and this point is C. Okay. And the star we can draw inside this. So the reason I am drawing inside is it will be more clear. Once I write the expressions, it will become more clear to you. So these resistors we will mark as RA. Here we have R1, R2 and R3, right? So take care to write RA opposite to R1 and we will write RB opposite to R2 and RC opposite to R3. Okay. So that we can easily remember the expressions. So what is the expression for RA? This is going to be R1 R2 plus R2 R3 plus R3 R1 divided by R1. RB is going to be the same numerator. So I will write it once again, plus R3 R1 divided by R2 this time. And what about RC? Here also the numerator is same and what will be the denominator? R3. Basically it's nothing but the numerator is the sum of product of two resistors. Okay. We have taken two resistors, we have multiplied them and added all of them. Okay. This you have to remember. In the denominator, it will be the resistor that is opposite to this. So RA opposite to R1, we have R1. Similarly, RB, R2. Similarly, here you have RC, opposite to that is R3. If you change the configuration also, so you can take RA here, RB here, RC here. Remember that the opposite resistor should be in the denominator. Okay. Next, delta to star. That means a delta connection is given. And how do we get the star values? So once again we will draw the delta here. This is the delta. So we will take the same thing RA, RB and RC. So now the connection is like this. This is the required star connection. So here you can take anything R1, R2, R3, it doesn't matter because there is another way of remembering here. So I will just draw the bigger diagram. It is not clear there. So R1, R2 and R3. Okay. So we can also draw this delta as well. So what are the resistances here? We have RA, RB and RC. Okay. So how to remember here? The star connected resistor R1 you can write as the product of, see in the numerator there will always be a product. Okay. For a star connection, this resistor is connected between these two resistors. So the product of these two resistors divided by the sum of resistors. RA, RB divided by RA plus RB plus RC. Similarly, you can try writing for R2. The R2 is connected between what? RA and RC. So RA into RC divided by the same sum. Denominator is going to be same. In the previous case, the numerator was same. And what about R3? This is going to be RB RC divided by RA plus RB plus RC. Okay. So this is the star to delta and delta to star transformation and how to remember it in a easier manner. Now we will see when the resistors are equal, then what will be the result. So let us say we have delta and we want to convert into star and all of the resistors are equal. Then here if you calculate, if you use that formula, then you are going to get R by 3, R by 3 and R by 3. So it is going to become by 3. Similarly, you can take the other side also, like if it is the same values R by 3, if you want to convert into delta, it's the same thing, right? So it is going to become 3 times of this. That means if R is here, then it will become 3R. So you can remember with a simple expression the delta value, the delta resistor, it is going to be 3 times the star resistor. Okay, so this is for when equal resistors are present. Are in star or delta. Okay, then the star delta transformation is given by this expression.